Welcome, everybody. Great to be here in another encounter of the Data on Kubernetes community. We're getting close to number 40 in terms of the meetups that we've done. Actually, and that would only be reflecting the meetups that we've done in English. We've now been doing some meetups in Spanish. Have some more coming on the way as well there too. Also doing meetups in Portuguese. We will be doing a meetup in Hindi at the end of this month that I'm very excited for. So I have to start learning basic Hindi just to be able to introduce myself. So that's exciting. But just for everybody out there, you know, as a constant reminder, we're always interested in diversity, inclusion in any way, shape, or form. And before we get started as well, I just want to let everyone know that our community has some very exciting news. All right, we're going to be participating in a co-located event in KubeCon. Right, so that also means that we're going to be having a call for papers for end user talks. All right, for 10-minute lightning talks that will be live on May 3rd. You have all the information here on the Linux Foundation website, and also on our website as well too at DoK Community, right, where we scroll down, you can see the schedule, right? Remembering that, you know, this is Europe, so we have all the times over CET. We have different talks that are on there from folks in China, folks in Europe, United States, Russia. We have quite a few different places represented, all talking about the very topic, a lot of things related to the same topic we're going to be talking about today with Prashant about running, not creating stateful applications, running stateful workloads on Kubernetes, all right? That being said, I would like to stop sharing my screen. Normally, I'm not the one sharing. Thank you, Gorka. It's very, very wonderful. You have a technical director who can help you with all these things. That being said, great to have with us here Prashant from Devtron Labs. Prashant, welcome to the Data on Kubernetes community meetup. It's a pleasure to have you here. Can you just give us a little bit of background about who you are, how you started working with Kubernetes, what you're doing at Devtron Labs?
Sure. So, my journey with Devtron Labs started in 2018. I'm a co-founder of this company, and we have an open source project called Devtron, which is essentially an open source AppOps platform for Kubernetes. That's what we do. So before starting this Devtron, I was the head of technology in a company which owns the sixth most used travel app in the world. And in 2016, when I was part of that company, I was very excited when I get to know about Kubernetes. Because throughout my life, while working as the CTO or head of technology, or even as a developer in different startups as well as large scale enterprises, I always felt this pain wherein we were seeing that application developers, even for smaller changes, they had to go to the DevOps team, and DevOps team would be doing all the stuff for them. Now, this is something which always pained me because I believe that this was not the right utilization of time, either for the application developers and nor for the DevOps guys, right? So they had a lot more things where they can add a lot more value to the company. And when I looked at Kubernetes and its philosophy, wherein they wanted to sort of hand over this thing to the developers so that developers are able to manage their applications by themselves, I was really very excited about it. And in 2016, so it was open sourced in 2015, Kubernetes, and in 2016, our journey with Kubernetes started in that company.
So quite early adopters.
But when we,
yes,
so we were actually we were early adopters, and our scale was very, very huge, right? So this company, so trains is one of the most frequently used mode of travel in India. And this is the company which has the most number of train app users in India, right? So it's like multi-million DAOs we are talking about, right? And constantly mobile DAOs.
Very, very silly question, typical American question. What's the population of India? How many people are we talking about?
Total population of India?
Yeah.
I'm not sure, to be very honest.
That's okay. That's okay. It's not a quiz. I can check right here. No, but because like you said, if we're thinking about the sheer numbers of folks out there, we're talking about a very, very substantial number of people. 1.36 billion, according to Google.
And people are gonna roast me because I don't know the number. But yeah, so it's the right. So Rajesh Razdan has also written it, right? So
thanks, Raj. Yeah.
So train app is so as I was saying, train is one of the most frequently used mode of travel, right? And it has a huge number, right? So with that huge number, without taking any downtime and moving on to Kubernetes was a huge challenge for us. We looked at a lot of open source products, right? Because since we were starting from scratch, I wanted to get it done right. Right. So the idea that I had that developers be able to own the application management operations, that's what I wanted to set out to do in that particular company. But what I found was something that sort of shook me to the core, right? Because there were a lot of open source tools which are available, but if you look at them, those open source tools were very verticalized in nature. They were not connected with each other, right? So you had to write a lot of glue code in them, right? And if you look at some of the very prominent open source of that time, the companies which sort of open source them themselves said that they have a lot of other pieces which work with this open source to make actual things work together. But those other pieces are so much hard tied with the infrastructure within the company that they cannot open source them easily, right? But as a company, that was like a huge setback for me. I couldn't see it happening. I saw that even though we had moved to the Kubernetes, the earlier thing was still happening. As long as you were making very simple code changes which were to be deployed, and there were no interactions with or changes on the infrastructure or the requirement layer around, developers could do it, right? So Jenkins job, you just put the branch name or you just put the tag name and you just click the button and it will deploy. But as soon as any complication happened, right, wherein let's say there is some change in the table name, there are extra properties which are required in the file, or anything which required more than just a code change, you would again be running to the DevOps team and telling them, oh, we want this to happen. And DevOps team will say, oh, our system is automated, but A, B, C, D has to be done manually, right? And that is what propelled me to think, why don't we have something like this? And that's where this whole Devtron journey started, right? And I'm very proud to say that because of this reason, we are open source, because we want to democratize this space. We want every company to be able to use this irrespective of their size. They should not be putting multi-million-dollar upfront investment so that they can have this AppOps and DevOps space to a level which is actually contributing to the growth of the company rather than restricting it. So this was the whole journey for me, which sort of prompted me to start this venture and take it to where it is today and try to sort of make it more popular among the like-minded folks.
Wow. Very, very good and very well explained. And like you said, I think a lot of times the issue of governance, the issue of independence, the issue of responsibility, sometimes culturally speaking, mentally, often we think in silos, like I'm a developer, so I focus on this. I'm an ops person, so I focus on this. I'm a security person, so I focus on this. And like you said, trying to make this more horizontal and sharing those that kind of knowledge is something that maybe some folks aren't ready for yet at an organizational level. But I think overall, much better to have, like you said, that vision that's being shared by everybody. That being said, let's jump into your presentation. Just a quick reminder to everyone in the audience, feel free to ask questions at any time, put them in the chat. We'll get to them accordingly. And if not, we can always take it to Slack as well.
So let me share my screen with you.
Okay.
Right. So can you see my screen now?
Yes.
Perfect. So just like quickly, what is the agenda that we'll be talking about today? We'll be taking up, initially I'll be talking about what is AppOps, because I saw there was a question about what is AppOps on the Slack channel. So I thought it would be a good time to sort of address this, that how we look at AppOps. Then what I would be talking about is the different ways that we can manage a state on Kubernetes. So here I'm not talking about the stateful set only, right? So whenever we think about state, we think about stateful sets. But I believe that there are a lot of steps that you need to cover before you actually say that, oh, the stateful set is something which is going to solve my problem. Right? So I'm going to talk about all those different mechanisms through which you can manage state on Kubernetes in a Kubernetes native way, as well as in the Kubernetes native way, as well as including the stateful sets, right? So that's what I'm going to do. Then I'm going to briefly touch upon what is the app, how can you do an AppOps for stateful applications. Again, in this particular topic, I'm going to give you more broader guidelines. We can do a detailed session later on whenever it is required, wherein I can go into depth of how operators can be built and how actually you can build a complete system which is AppOps enabled for stateful sets. But in this case, I'm just going to give the guidelines of how do we envision it and how do we sort of incorporate it within the Devtron product that we have built. Right. So to start off, I think to understand DevOps, it's important for us to understand, to understand AppOps, it's important for us to understand the historical perspective of DevOps. For most of the guys who would be on this call, I believe that when they started working, DevOps was already a well-established principle, a well-established way of working, right? But for people like me, who started off way back in 2004, DevOps at that point of time was a phenomenon which was kind of non-existent, right? In fact, my first job was for a company which is a very, very big multinational company in US. I was working for that company in the offshore development center. And when I joined that company, they were for quite a few years, they were already in the process of migrating their Oracle ERP system from 9i to 10G. Right? So it was 2004. I moved out of that company in 2006 into to do my MBA. And even in 2006, that product was still not live, even though technically the development was completed in 2004 itself. Right? So you could see that it took them like more than 1.5 years, and still they couldn't come out with that piece. That was the state which we had kind of a 2004, 5, 6 kind of era, right? And that's where this DevOps principle was actually proposed by the people. And again, if you look at that, you would realize that because of this precise reason, there was too much emphasis in the DevOps system was given to the culture, people, and process, right? Because you didn't have tools which were mature. Those tools were non-existent at that point of time. And companies would not want for the maturity of the tools to happen to actually have a stable deployment, right? At a fast pace, at a high velocity. So what they did was they said that culture, people, and process is at the center of this DevOps movement which is happening. And tools is something which this team will build over time, and tools should not be a reason why they can't move forward, right? But I believe that that was a reality of that time. Now fast forward it today. You have all the capability to build all kind of tools. You have those uniform APIs which are available, right? So tools, I believe, now should be the one who should be driving the second phase of improvement on the DevOps side. And this is what we call AppOps also, right? So to tell you further about AppOps, let me first tell you what AppOps is not, right? So infrastructure management is not AppOps. What I mean by infrastructure management, if we are talking about Kubernetes specifically, if you are doing things on the cluster, you are upgrading the OS version, or you are upgrading KTS version, or you are making certain changes in the node for a better management, adding nodes, removing nodes, adding affinity to the nodes, right? Creating policies for the cluster, what kind of things can be deployed on the cluster, what kind of things cannot be deployed on the cluster, right? Or you are defining cluster security, which ports can open, whether you can run an application as a node port, you cannot run an application from a particular namespace as a node port, can you create a load balancer as a service or not? So all these kind of policies which can impact, let's say, the cost of running the cluster or the security of the cluster. All of these are also part of the infrastructure management. What I also add to the infrastructure management are the third-party softwares. What I mean by them are, for example, if you have a Kafka, if you have a MySQL, or if you have a Postgres, or a MongoDB for that matter, right? So softwares which are not being developed by your company, but they are still being used by your application team, but they are not the primary owner of the code of those softwares. So these softwares are again primarily managed by the DevOps team or the infrastructure management team, as you may call it. So these are the pieces which management of these things, upgrade of these things, they are not part of the AppOps as we envision it, right? So if now I have to define AppOps, I'll say that AppOps from a 1,000-feet view is a platform. What it does is it does two things primarily. One, it allows DevOps to create the guardrails, the policies, using which the developers can act within the framework, right? So it is an effective way to delegate to the developers. And for the developers, it is a system which abstracts out the information in such a way that the developers can handle the applications, manage applications by themselves without involving DevOps for every small thing, right? So that's how the AppOps thing looks from a 1,000-feet view. If you have any questions at this point of time, please let me know. Otherwise, I'll move forward to how do we break down the AppOps into multiple components? What are the different components which actually make part of the AppOps?
Yeah, I guess you're seeing it from the perspective of the guardrails factor. You know, what are the risks that companies are running if they don't have those guardrails in place?
Yes. So actually, we have seen huge impact on companies if those guardrails are not in place, right? So So though we are saying that developers should be the one who should be managing the applications, but understand this, that applications can potentially create a huge impact on the cluster, right? You are running application as a root, and that application is exposed externally, right? This thing can actually create a huge problem wherein a hacker can take access of it. They may be running their own loads, right? So in fact, there was a case wherein in Tesla, they found out that Tesla cluster was being used for mining Bitcoins, right? So all of this happens because what you have done is you have not provided the guardrails or the policies to safeguard the system for the developers. Developers don't know Kubernetes as such, right? So they have too many things to learn about on the technology front. Otherwise, they are not gonna go deep in just on the infrastructure side, which itself requires months and years of training and learning, right? So that is why these policies, how much RAM can you how much RAM and CPU can an application consume? If let's say you have not defined the RAM and CPU for an application, that application, if sort of runs away with the RAM and CPU, can actually destabilize a lot of other applications which were actually behaving correctly, right? Even they can be destabilized, they can be starved for the resources, right? So these kind of issues and challenges can only be taken care of if you have the right guardrails. Mm-hmm. Another example of guardrails might be wherein you are saying that there is a junior developer which has come in and you are saying that you can deploy to, let's say, production environment. Now, the person may deploy code from QA to production environment if he or she is not aware of it. Now, guardrail will ensure that only a code or a container which has been created from the master or the main branch gets deployed to production, right? So these are the kind of guardrails which ensure that your system at all point of times is compliant and is not compromised.
Good, excellent, thank you. We've got a question here from Waleed. We have many tools. Our problem is culture, mostly focus and fighting on tools and how to use them. Isn't that platform as a service equals AppOps?
So yes, so I look at it from a reverse way, wherein I say if you are doing an AppOps, then it has to be done in a platform as a service way. Now that platform as a service way doesn't have to be done necessarily by an external team. It can be done by the DevOps team also. So AppOps has to be done via platform as a service way. That is, I completely agree. About the tools things where you say that the team is fighting, and that is where we are taking a radically different view, right? What we are doing as Devtron is we are not taking a lot of opinions about how things should be done as long as they are the best practices, right? So for example, you are doing GitOps, right? Some company may be using Flux CD for GitOps. Another company may be using Argo CD for GitOps. We as Devtron don't make an opinionated view whether Argo CD is better or Flux CD is better for GitOps. You want to use Argo CD for GitOps, you can connect with Devtron, and it will sort of delegate that GitOps flow to Argo CD and will work very, very closely with Argo CD to sort of bring in those parameters which are missing in Argo CD. Similarly, if you're using Flux CD, Devtron can work very, very closely with Flux CD and just providing those parameters which are missing in Flux CD, right? So what we are trying to do is to provide you a platform which allows you to onboard onto the best practices very soon. The opinions that we carry are not about which tools you should be using, but more about how they should be used, how they should be interacting with each other, so that they don't impede you, but support you. So does that answer your question, or do you have?
Are we good, Waleed? Yeah, because Waleed also made another comment about self-service and delegating. Okay, anyway, he seems to be okay. Thank you, Waleed. Shukran. Let's keep moving.
Sure. So if I have to break down the AppOps that we were talking about, I look at it as the three major components to it, right? So one is the stability of the application. So whatever is required to make applications stable, there are a host of things which needs to be done, which are mentioned on this chart, but I'll not get into the detail. So that's one aspect, is the stability. Another aspect is the cost. And third aspect is the security. So these are the three things about which an application owner is concerned while running his application on infrastructure, right? So the AppOps system should allow application developer to fine-tune these three parameters in a way so that he doesn't have to learn a lot about infrastructure but still is able to do it. Right? So those are the three components of the AppOps, the way we look at them. Now, what is it that enables a company to have DevOps, right? AppOps. So if let's say you are building an AppOps within your company, what are the major components or what are the main criteria that it has to meet for it to actually be an AppOps platform and not just a mishmash of multiple tools, right? So as I talked about, there are three things which are important, and these five things have been sort of taken out of them. So one thing is that the developer should be able to do things by themselves. What it means is that data which is being collected from all different places should be brought together. Now, with Kubernetes, again, the complexity has even more increased, right? So earlier there was cloud provider and then there were applications. Now there is a cloud provider, then there is Kubernetes, and then there is application. The data is spread all over the place. Moreover, now we are working more with microservices, which are working with maybe Kafka, RDS, and too many other microservices also, right? So the data is now humongous and is at disparate places. So it's very, very important that we are collecting data from different places together at a centralized place so that developers can look at that data and make sense out of it. Now, is it easy for them to make sense out of it? The answer is no. And that is why you need to provide the right level of information abstraction. You can't expect them to learn cloud providers, right? How AWS works, how Azure works, how Google works. You can't expect them to know intricate details of the Kubernetes either. Only thing that they would know more about is their application. And that is why it is important to present information to them in the right abstraction, right? And at the same point of time, this information which you are presenting should also be intuitive for them. The case in point is Kubernetes itself, right? So Kubernetes is very, very versatile. It's a great piece of software. But the learning curve for Kubernetes is way too high because it doesn't have any intuitive UI to guide you to the right direction. It has huge knowledge base, great knowledge base, but still people are struggling. And if you look at it, more than 30% of the companies who have adopted Kubernetes say that they are still struggling with the complexity of Kubernetes. And believe me, I think that's an understatement. Most of the time they would have talked to people who are good at Kubernetes, and then they said 30% of them said that, oh, Kubernetes is complex. Right? So that intuitive UI, which can sort of guide person in the right direction so that he doesn't have to learn or he doesn't have to get a certification to be able to use the system. That is the third requirement for the developers to be able to use the system by themselves. Right? And then guardrail provisioning is something that I have already talked about, because DevOps teams should be able to control and developers should not be doing whatever they want to do within the system. It's not that they have malicious intentions, but it's simply that as developers, we all have our own SLAs to meet, right? And because of that, we may take certain calls which may not be best for the company, but may work in the short term, right? And then collaboration is the third aspect, which is of course critical. When I talk about collaboration, I'm not just talking about the collaboration between the developers and the DevOps team. I'm even talking about collaboration between multiple development teams across, right? So with the microservices, again, multiple applications are working together. A failure at one end may result in failure in some other application, right? And then it becomes very, very difficult to debug as to where this problem originated. And that is why a collaboration wherein different people can sort of effectively work together without having to share a screen, without having to take their laptop and sit next to each other. Of course, that has become very, very difficult with this COVID scenario. But earlier it was a normal practice, right? Wherein developers and DevOps would move into a war room, take their laptops together, or they would be sharing screens, or they would be saying, oh, I'm looking at this, you look at that, and try to sort of get to the root cause of the problem, right? That collaboration is too much offline, right? So that collaboration has to be part of the software itself, wherein you should be work together on certain pieces of software while fixing the issues or debugging the issues. So that's the third aspect, the collaboration, which is the core of the AppOps platform, right? Which makes AppOps possible. So with this, I'll quickly go through like how Devtron does it. So Devtron essentially, what I just talked about earlier, Devtron does the same thing. It gets data from a lot of different places. It presents to you in an intuitive fashion, in a right level of abstraction, so that you can make sense out of that data easily and decide what is the next action which is to be taken. Of course, it allows you to complete the cycle also by taking those corrective actions using Devtron itself. right? So once you have identified the issues or you have figured out a point of improvement, you can directly go to the system and take those actions by yourself directly, right? So these are some of the things that Devtron does, and here are some of the screens of the Devtron system. Now let me get to the main aspect of the presentation today. So as I was saying, so what we are gonna talk mainly about are the different patterns which you can use to manage state in Kubernetes. As I said earlier, I'm not necessarily talking about the stateful application in this case. I'm talking about cloud native ways of managing state in Kubernetes, right? I have not included managing state externally in, let's say, MySQL or MongoDB or Elasticsearch, these kind of state management systems. But only those ways of managing state which are provided by Kubernetes itself, right? So first and foremost is to use a single replica deployment with PVC. I guess most of you might be wondering why I'm even mentioning it, as this is something which you should be avoiding at any cost, right? Because of the inherent limitation that it has. You can only run one replica at max, right? So if you try to run more than one replica, in this case, when you're using a deployment with a PVC, the other pod will never come up because it will keep on waiting for the same PV, which has already been attached to the first pod, right? But interestingly, when Kubernetes came in and Helm charts sort of started coming up, this was the most often used method, even by the stateful application. For example, GoCD, which is another way to do CI and CD compared to Jenkins, which is sort of created by ThoughtWorks. It's an open source system. They were using deployment, even though they were managing a state. They used to store XML of all the actions that they had taken in their hard disk, but they were using deployment and not a stateful set. Similarly, the initial Helm charts of MySQL, they were using deployments and not stateful set. But as I said, this is something which should be avoided because there is only one replica which is running. That means whenever you're doing an upgrade, there is definitely going to be a downtime, right? As well as if, let's say, because of some reason, there is an eviction which has happened of pod, again, there will be a downtime because there is only one instance which is running. It can also create problem in case of a multi-AZ system, right? The reason being that if, let's say, you are in a multi-AZ system and Kubernetes, let's say, decides to rebalance the load. So initially, let's say this system was created in zone 1, but now after rebalancing, this system is supposed to be moved to zone 2. The PV that has been created cannot be moved to zone 2. So the cloud providers don't support that, right? So because of which, again, in the multi-AZ system, it may again start creating a problem for you, right? So this, from my perspective, is a system which I've included just for the historical sake, but this is something that should never ever be done, right? I don't believe that a stateful set is complex, so that if you have to run only one replica, you should be running deployment. Even if you have to run only one replica, please use a stateful set. Unless your requirement is being met by some of the patterns that I'm going to talk about now. Please feel free to stop me at any point of time if you want to know more about it, how it is to be done. I've put a small snippet on the site to say like how it is done. I've only included those most critical things to make it work. But if you would want to know more about it, I'll be more than happy to answer them. Right. So now coming to the deployment with a shared drive. So in this case, what we are doing is in all of the pods. So deployment has pods, but in all of the pods, you are mounting a drive, which is a shared drive and an FS kind of a drive. In case of AWS, it would be an EFS drive, right? So that is what you're mounting in this particular case, right? So this is typically slow because it's a network drive, right? Network file system. Also, there is a possibility of data corruption in case there are concurrent writes which are happening on the system, right? So so your question might be like where it can be used and where it cannot be used. So the way I look at it is we have seen few systems where it has worked beautifully, and I think that was the right way to use it. For example, there was a coding testing system. So there is a proctoring system wherein there is a company which allows you to conduct coding tests for other people, right? Now, when people were actually coding on their system, what they were doing was whatever was being written was being automatically saved into the drive. Now, this drive was a shared drive, so that if because of any reason, any point of time, that pod got evicted, whatever the user has written, whatever the test taker had written was saved in the drive. And whenever that pod was getting recreated, it would use the same drive, and therefore whatever was done by the user was immediately available to the user, right? In this case, there were no concurrent writes which were happening. Could it have been done with a stateful set? The answer is yes. It could have been done with a stateful set also. But in this case, for them, it was easier to do it with a network drive. The reason being they didn't have the problem of fragmentation of drive, right? Because if there are 1,000 test takers, now you suddenly need 1,000 PVs for those 1,000 stateful sets. But in this case, the drive is still one. So the fragmentation of the drive was not happening. That was one of the things because of which they decided to use this rather than a stateful set. All right. So this was one of the cases where we have seen it working perfectly well. Another thing was our train positioning system, wherein in the company where I was working previously, we had a huge Spark cluster which was consuming data from Spark. Which was consuming data from Kafka, and it was trying to figure out what is the exact location of the train right now, right? And it would use a lot of previous data also to figure out, to sort of cull out those GPS parameters which it thought were, let's say, which arrived late or which were wrong, right? So in this case, again, what we were doing was, because Spark is a very, very fast system, it needs very, very low latency. So what we were doing was, we were again using a network. Whatever data we were calculating, we were of course storing from memory itself. We were just storing data drive. We were not reading it. We were only reading it if because of some reason the pod got evicted, right? So when the pod would first come up, only at that point of time it would read. Otherwise, it will just keep on writing. Again, in this case, there is a lot of fragmentation, a lot of trains, their timings, and a lot of issues. And because of that, we decided to move ahead with the network drive rather than a stateful set. Another system where you would think that it would work, but actually it would not work, is a CI system, right? The continuous integration system. So we at Devtron also have its own inbuilt CI system, which is written on top of Argo workflow. Now, in the case of CI system, you may feel that we can use a network drive to sort of use the cache of the container, right? So the container engine, the cache that it creates, I can use a network drive to store that cache and reuse that cache. But the biggest problem over there is multiple builds can run parallelly. Because of that, there may be a lot of concurrent access to these drives. And this may result in the data corruption, right? Some of the builds may be using older, let's say, MNN files. Some of the builds may be using newer MNN files. They might be thrashing the same disk, and they may result in a data corruption. So in this case, the better and what we used was the strategy wherein we used a centralized cache. So once everything was done, we would just sort of zip it into a file and move it to S3 or another object store. And whenever a new CI is required, we will pull it from that store and expand it and use it as a cache. So in this case, that worked for us beautifully. This disk would have not worked at all. Does anyone have any question related to the deployment?
We got another comment from Walid. He says, I have an internal registry as a deployment with RWX volume and FS, and not sure where the issue is with the deployment with 3 replicas.
Where is the issue?
Yeah, he says he's not sure where the issue is with the deployment with 3 replicas.
Let me see if I've...
Yeah, if you just open the chat, it should be right there. He says, I do not see any issue with shared drive use case.
So, so my question to you, Walid, would be, this internal registry that you have, what is the read-write concurrency for that, right? So are different replicas writing to different directories? Are they writing to the same directory? What is the TPS at which they are doing it, right? So these are the questions based on which we figure out whether network drive is the right choice or not, right? So in our case also, as I was saying, in the coding test system as well as for the train positioning system, in both the cases, network drive worked beautifully, right? So another advantage of network drive is that everything is available to you as a disk, and that's why any command that you can run on disk, you can run on the system and debug issues, right? So I'm not saying that network drive doesn't work. In this particular case that you are discussing, okay, I think he has put in another comment wherein he's saying that I don't see same directory. I know object storage is the best, but on-prem sometimes you can get it. Right. So in this particular case, again, as you are saying, latency is not an issue for you. So in that case, it again makes sense, right? So deployment with network drive, I believe, makes sense in certain use cases. It's not a never no kind of a thing. Which I was saying for a deployment with a single replica set, wherein I was saying that you should never be doing it. If you have to do it, rather create a single stateful set with single replica rather than using a deployment, right? But with network drive, as you have mentioned, in your case, it might make perfect sense to use a network drive because of the simplicity of the system. And if you are okay with the kind of latency that it is introducing, it makes perfect sense to use it rather than going for any complex design, right? So in fact, towards the end of the presentation, I've also talked about the Occam's razor, right? So same thing can be achieved via different solutions, right? So most of the time you'll find the case wherein same problem can be solved with, let's say, 3-4 different solutions. So which one you should choose? You should choose the one which is simplest to maintain, right? So so it's all trade-offs, right? So the idea for me is only to provide you with the list of these trade-offs. So that whenever you're doing it, you are cognizant of those trade-offs and take the call accordingly. So again, I think registry, it makes perfect sense for the NFS. If the concurrency requirement is low, the latency requirement is not way too high, it makes perfect sense. Do we have any other question, or should I?
No, keep going. Keep going. You're good.
So, right. Now, this is something which I think people on the DevOps side might have thought of, but at least from the application development side, people most of the time don't even think of it, right? So, and in fact, over here, I'm cheating in a way because I'm still externalizing my state, right? But as I said, I never said that I'll only be talking about stateful set. I'm talking about managing state on Kubernetes in a cloud native way. So that's what we are doing, and config map secret is a perfectly cloud native way of doing it. And there are a lot of tools which are available today which use config map and secrets to store data. Some are good practices, some I believe are not good practices, and you can see them for the same set of tools also, right? So just to give an example, Argo CD stores your data, stores the data, the cluster the cluster configuration that you provide to the Argo CD. It is stored in secret, right? I think it's one of the best ways to store the sensitive data because Kubernetes already provides a lot of mechanism to safeguard secrets, right? So this gives you the benefit of using something which Kubernetes already provides. So it takes away the maintenance hassle from your head, as well as this is already accepted as a best practice for storing sensitive data. Where I think that they are not doing a great job of using config map or secret to store data is even, for example, they store the configuration of the repositories, right? The Helm repositories or the Git repositories. Now, if you go and look at the Argo CDCM, you would see a huge list of these configurations. I think that's a pretty bad choice. The reason being that inside config map and secret, everything is a string. It's not structured data, right? And because of that, what happens is whatever validations you're putting it within the code. So I read a config map, I make certain changes, and I push it. Now, because the revision has already been updated, API server may fail it. I may get it back. But now it becomes much more difficult for me to figure out what exactly had changed, because this data is a semi-structured data, right? And it would require me to do a lot of string manipulations to figure out actually where changed, what changed, right? So a lot of offloading of that algorithm, of that code on the application developer side. So that's where I believe it's not a right choice to use config map or secret if you are storing small amount of data, right? As I said, some sensitive data, or let's say even if you're storing some data to, let's say, coordinate between multiple replica sets. So they may be listening to the same config map, and a change by one of the replicas may trigger action on other replicas, right? So those kind of things you can use config map and secret for. In fact, Helm again uses secrets to store the complete manifest, right? So that it allows it to be a very lightweight client now. Earlier it had Teller, which was creating a lot of security issues for the folks managing operating clusters. But now it had moved to a very light model. And in this case, what it is doing is all the manifests which have been generated, it is sort of zipping it and then encoding it and then putting it into the secret, right? Again, I believe a great use case of using config map and secret. And as I was saying, so the example that I gave of Argo CD, wherein I see that you have non-normalized data and you have very many rows of that non-normalized data. That's where I think now you have started abusing config map and secret, because that one single config map and secret will become huge. And then again, there is a limitation on the etcd side of the maximum size of the data that you can store. So you will again run into that limitation also over time. So this might be fine for Argo CD because they want to have very limited dependence on other things so that people can easily install it and get started, right? But I believe it creates huge problem at multiple ends. And this should only be used when you have very small data. It can be dynamic, which is perfectly fine, right? So you can change data in config map, and other replica sets can read that data and further manipulate it. That's perfectly fine. Having a dynamic data in config map or secret is perfectly fine. What is not fine is when you are doing it for a humongous amount of data, non-structured data, multiple rows. That's where I think config map and secret should be avoided completely. Extension of this is using CRD, right? So custom resource definition is something which is used quite often in Kubernetes, but I believe that this is primarily used by people, again, who are building stuff for Kubernetes. It's not being used as much by people who are application developers. Again, I'm not recommending that you should be doing it a lot. The reason being that the more you do it, the more you are putting stress on the API server and the etcd, which is backing it, right? So if you sort of throttle it, your whole cluster may become unresponsive, right? Of course, Kubernetes can survive with API server not being available for some time, but understand this thing that if some pod is evicted, it will not be rescheduled, right? It will not be restarted. So those kind of problems you will start seeing in your cluster. So I believe that this system can be used only if you are dealing with a medium scale data, and primarily when you're kind of writing a state machine, right? Again, one of the best example for this is the Argo workflow.
Oh, and really quickly, just another comment regarding etcd. So etcd storage limit, the default storage size limit is 2 gigabytes, configurable with quota backend bytes flag supports up to 8 gigabytes. Then etcd is designed to handle small key value pairs typical for metadata. Larger requests will work, but may increase the latency of other requests. By default, right, the maximum size of any request is 1.5 MIV. There we go. This limit is configurable through max request bytes flag for etcd server. I know this because I used it to break a cluster for David Rocco's Cluster D episode 2. Right, so Waleed, you've done your homework. Very, very good.
It's true. It's very true. In fact, recently I was talking to one of the companies, and they were saying that they wanted to use a cluster orchestration, not cluster. They wanted to do a microservices orchestration, right? And the unique way about the way they wanted to do microservices orchestration was they wanted to use Argo workflow, right? So let's say a request came in, Argo workflow would decide which all microservices the request should be sent to, right? And this is what they wanted to do. And I told them, boss, you shouldn't be doing this, because etcd server and API server are not built to handle this kind of scale. They are not, right? So, so my point is that you can use it, but you have to use it with concern, right? So you can't just be non-worried about it. But having said that, this I believe is again something that you can definitely leverage at times, right? So as I was saying, so Argo workflow is one such example. You have other systems like Airflow and others which are using actual DBs or Celery, which are using actual DBs and queues to actually orchestrate the state machine. But if you look at the Argo workflow, what it is doing is it has created a CRD, which acts as a state machine. So whenever it makes certain changes and it submits it to the API server, because it has an informer cache which is also listening to all the changes, API server just sends back, right? And again, based on the state of that particular CRD, it decides what next action it has to take, right? So again, an excellent example where you can use CRDs to actually hold the state. Most of the time, it makes sense if you are mutating the state and not just holding it, right? So in the same sense, one of the wrong use cases, I believe, is in the case of Argo CD, right? So Argo CD has an application object which stores all the data related to the actions which has been taken on Git repository, right? So whether it was able to pull data from the Git or not, whether it was able to generate templates or not, whether it was able to apply those templates, as well as what is the live state of those objects, right? And it stores all of the data into the application object. Now, why I believe that's a bad choice is because Argo CD is not actually running a state machine, right? It is using it actually just as a data store. Now, the repercussions of this is that you can't store infinite history of the application object. So there is a limitation on how much history you can store, and it of course increases the size of the data. It increases the size of the application object. It becomes difficult to understand what is written in the application object because of so many history elements, right? So you keep on having those more and more application objects, right? Bigger size application objects. So that is why I believe that Argo CD, in this case, I believe their primary criteria was to get started easily, right? So you just take it and you start it. Redis is the only external piece of software which they are using, right? Of course, they also run one instance of DEX, but I believe, but DEX is something which is also like an embeddable library, which if you want to use. So I don't consider DEX in the same category. But Redis is the only system that they use. They are not using any MySQL systems or any other systems, right? And that is why they decided to use application object instead of them. But as I said, I believe that it's taking it to the extreme because you are not using it as a state. You are not mutating things. You are just using it as a data store to get data for later on, right? And again, because of this, Argo CD is not able to provide a lot of analytical data which you might require for deployment, right? So they say that, okay, because everything in Git, you can go ahead and check from there. But they have limitation in the amount of data that they can provide for the history and how far back in the history they can go. Right? So this is what I believe how you can use CRD. Again, this is something for which you need a good experience of Kubernetes. I have put certain links at the bottom. Earlier, my thought was to go through them, but I think that I'm already sort of exceeding the time limit. So, but they are in the bottom. You can go through them. This will give you some idea of how things are. And you can always ask me questions on the Slack channel also later on if you want.
Definitely.
So now moving on to the big stateful set, right? So a stateful set has its own use case. I agree. For things like MongoDB, for things like Postgres, for things like Kafka, it makes a lot of sense to use a stateful set. But I believe that if you are writing a stateful set as an application, you should seriously and very seriously question it. What is the use case because of which you need a local data store? Right? There are use cases. I'm not saying that there are no use cases, but you have to be very, very cognizant of what those use cases are. Because if you're gonna create another MongoDB or another Postgres or another Kafka as an application, I would seriously suggest not do it, right? Because a stateful set, in a way, and it has been said quite loud and clear that a stateful set on Kubernetes is still far from what it should be. I'm not saying that you cannot use it in production, but it is not able to handle all the use cases which are required for a stateful set. And that is why we are seeing that there are a lot of operators which are coming, the Kubernetes operators which are coming in for managing stateful sets, right? So you have Kubernetes operator for Elasticsearch, you have Kubernetes operator for MongoDB, you have Kubernetes operator for Kafka. Why? Because it's not trivial to upgrade the version of the application for these kind of third-party softwares, nor is it easy to change the size, right? So let's say initially you had given 100 GB of space for them, and suddenly you are hitting the limit. And rather than truncating the data, you may want to increase the size of PVC. It's not trivial. With the stateful set, it's not trivial. There is an open issue with them for quite a long time, wherein they said that let's simplify it, right? But it's still not has been worked on. So stateful set, that's why I'm saying like a stateful set is something that I say that you have to really think about, use it for cases which are comparatively simpler, right? For example, some of the use cases that I mentioned, in certain cases, you may want to use a disk-based caching, right? So in fact, one of the softwares that we are building, open source softwares that we are building for debugging, what it does, it gets data from all the clusters related to all the events which have happened, as well as all the object mutations which are happening. Now, if let's say you have 100 clusters, this data becomes huge. By default, the Informer cache, which is provided by Kubernetes, it stores data in memory. And in this particular case, it becomes infeasible to store all of that data into memory, right? So what we have done in that case is we have sort of overridden the code using some unsafe operations in Golang, so that instead of using in-memory cache, it's using on-disk cache using Badger as the underlying embedded database. Right? So in this case, we had to do it because we could think of pushing it into DB directly, but usually the kind of throughputs, especially for the events we were seeing, momentary latency was creating a lot of flow over onto the memory, right? So it was creating a lot of memory pressure for the application, which the application was not able to sustain. And that is why we were forced to use the on-disk system for caching. So that's one of the cases which you may have wherein you are using a stateful set. Another very good use case of stateful set is using Kafka consumers, right? So you are processing data on a Kafka consumer, and you might want to store intermediate data for later usage when you would be processing next batch, right? So again, one of the examples for this is again in my previous company where we were doing caching for the airline airfares, right? So what we were doing was, let's say if you did a search on our system and you are logged into our system so that we can identify you, then what we would do is we would note it down, like at what price point you saw, at what price did you see the ticket, right? For that particular origin destination pair, and for what date range. And we will constantly keep on monitoring all the price points that we are getting. And whenever we see that there is a good drop from the price point that you've seen, we would send you, and you have not booked the ticket yet, booked the ticket with us, we'll send you a notification that there is an X amount of drop in the airfare. And once we have sent you a notification, we would not bombard you again and again and again, right? So let's say price fell down by 500 and price fell down by another 200 in, let's say, next 1 hour. We would still not be sending you mail, right, or notification. So in this case, what we needed was, there was a very high throughput processing which was happening on the prices, and it was a complex process which happens because what is the origin, what is the destination, what is the date, how many passengers, what kind of flight, it's an economy, it's a premium ticket, right? So there are too many permutation combinations which go with an air travel. And because of that, there were complex competitions which were happening. Now, in this case, we were using a local data store to store the computed data that we had and use it to compare against the new data that we were getting. Right? So in this case, again, we didn't have much of a problem with the stateful set because even if, let's say, we had to upgrade or something, we could do it easily without any problem. And even if there was a downtime, it's okay, because at max, what would happen is we will fail to notify you of a price drop, which is not a huge crime, right? So we could live with that level of non-availability of data or non-availability of the state of the replicas. So in this case, again, it made a lot of sense for us to use the stateful set. Where we should not be using a stateful sets, if you can solve cases with any of the previous instances, or by externalizing the state to, let's say, MySQL or MongoDB or whatever stateful store you want to use, I would seriously suggest that you should not be using a stateful set. It's kind of a hydra which takes on its own life form over time, right? So just to give an example, these are some of the challenges, right, which Elasticsearch operator, TIDB operator, MongoDB operators are trying to solve. Wherein they are saying that even when, let's say, you are trying to downscale a node, how easy it is. It is not that easy, because actually the node that you are downscaling may result in a data loss. What if, let's say, the shards were, in case of Elasticsearch, let's say if because of some node outage, already the shards were in yellow and you brought down another shard, another node which had only that shard, what would happen in that case, right? So downscaling of nodes even is not trivial. Similarly, PVC, as I was saying earlier, increasing the size of PVC is not, again, a simpler matter, because you can't change the PVC size by updating the spec of stateful set. It's not supported. As I was saying, there is an issue open for it, but there is a lot of debate going around it. Nothing has been done on it till now, right? Even the backup and restoration of data is not that trivial in most of these cases, because you have multiple shards, dynamic data, which is working together. So how do you restore that data which you had backed up? It's not trivial again. I would not be getting into too much detail of it. As I said earlier, I just wanted to touch on a higher lines. If we want to look at how do we create an operator to manage a stateful set, that's something that we can look at later, wherein it would be more technical with the complete hands-on stuff. But for this, I think this is something that I wanted to highlight, like what kind of problems do you get into while managing a stateful set, and because of which you should be avoiding stateful set as much as possible. So, so this finally is kind of a gist of what we have seen till now. As I was saying, please use Occam's razor if you can solve something. If you can solve the same problem with a simpler solution, please use it. Stateful set, it looks simpler, it looks easier to use a stateful set, but actually managing a stateful set is way too complex compared to managing a simple deployment kind of stuff. If you have any questions on this or any comments on this, I'll be more than happy to take them.
Mm-hmm. I think we're good for right now. So yeah, just keep going.
Perfect. So with this, I think the only point that is left for me is, again, at 1,000 feet level, to tell you like what AppOps for stateful applications would actually mean, right? So if you are doing if you are building actually stateful applications, right, and not just using third-party softwares. What I would want us to be doing is to create one pattern which would be used across all stateful applications, right? So those stateful applications would be exposing a consistent set of APIs with which the operator can interact and make and request them to do certain actions. For example, if you're doing a scaling in, right? If you're doing a scaling in, you may want a particular node to be taken out. If you're gonna take out a particular node, you should have a consistent set of API, which if you call for that particular node, it should work on migrating its data, the data that it has, to other nodes so that it can be safely shut down, right? So what is important for you is to create that uniform layer of APIs and a uniform pattern, which your operator can interact with without requiring any customization, right? This will make your life very, very easy for managing a stateful application, right? So again, these are certain things that you would have to do if you want to run a stateful application via AppOps platform. There would be tons of parameters that you have to monitor, including disk I/O, the size of the disk which is being utilized, apart from the network traffic and RAM and CPU, and the number of replicas which are available, right? Then you have to write as I was saying, then you have to write a generic operator which would be taking care of these host of things. What's the deployment strategy? If you have to do a scale in, scale out, how do you do it? Multi-AZ tolerance, as I was saying, stateful sets by default are not multi-AZ compliant. So how do you ensure that this non-multi-AZ compliance doesn't result in non-availability of the application? Similarly, cross-region replication, how do you support it, right? So the data is replicated across regions so that the stateful sets are able to perform properly, whether it's active or active passive mode. How do you do that? Backup restore is of course there. Then security, cost visibility. How can you figure out the cost of running the stateful set? How do you tune it? Again, tuning may require right sizing it, changing the size of it, and it may again go back to the generic operator. In fact, if you look at it, security, cost visibility, ISO identification, and debugging, all of these three will loop back into the generic operator for deployment, because once you have identified it and you have to take action, 99% case of the time, in case of stateful sets, you would have to loop it back via the operator to do it in such a way that the services are not disrupted. I think with this, I'll conclude it. So,
but we do have one quick question from Sardier saying, for a classic stateful web app, let's say an online store, what would be the best way to deploy it, given that today it's a monolith?
Okay, so when you are saying it's a stateful web app, are we saying that the state is stored on the disk itself for that particular application, or it's still like it's actually stateless in the sense that the state is actually outside and let's say stored in a MySQL database or a Postgres database?
So stored on the database, yeah, Redis caching.
So if you are storing it on a database and which is not an embedded database and you're using a Redis cache, then it's actually not a stateful web application, right? So it's a stateless application. So we call an application stateful only if it is storing the state by itself, right? And that is why I said that when I talked about storing state in config map and CRD, I said that I'm actually cheating, right? So because that application is actually not stateful, I have offloaded that state to an external entity, which is an API server in that case, right? Similarly, in your case, the way I look at it, this is not a stateful set, and I would this should not be done via stateful set for sure, right? It should be done via deployment. What are the strategies to deploy a monolith? Usually, in case of monolith, what I see is that the blast radius is huge. Because a monolith, in a monolith, multiple developers would have contributed to it, right? And because of that, the quantum of change which is going out with the monolith is huge. And whenever the blast radius for you is huge, in terms of the changes which has happened in the application, you need to reduce the blast radius in terms of the exposure that is being given to the number of users who are using it, right? And how can you do that? You can usually do that by using things like canary deployment, which is not, of course, not provided by default by Kubernetes, but there are plethora of ways to do canary deployment. So what canary deployment will allow you to do is to say, let's say, you can reduce the blast radius to 5% of the users and monitor it so that you know whether there is an issue with the deployment or not. If it is not, then I would suggest you to switch to the blue-green immediately, right? So usually what happens is people will say, okay, 5%, then 10%, then 15%. I don't think that's the right way to look at it. Once you have a statistically significant data to say that your application is working correctly, then you should immediately switch to blue-green. What blue-green, the advantage that blue-green gives you is that in case of any issue, you can immediately switch back to the previous version. Right? So that's the advantage of blue-green. Of course, the requirement of blue-green is that your both of the versions, and in fact, that's the requirement for canary also, that your both of the versions should be able to run concurrently, right? So that's one requirement. But having said that, in your case, this web application, I'll not call it stateful. It's a stateless application because state is being maintained outside on database and on Redis. So you can use a deployment object to deploy the application. And as I was saying, I would suggest that you use canary, mix of canary and blue-green for the deployment, simply because it's a huge monolith application. I think it's important to control the blast radius. In most of the cases, the testing for these applications is not adequate. It's difficult actually to do complete testing, and because of that, a lot of issues come post deployment, and that is why I would want to control that. Does that answer your question? Am I missing something? Is there a state which is being stored on the system itself? If that is the case, I would like to understand what's the size of the state. Is it few properties file that we are talking about, or we are talking about complete embedded database, let's say like SQLite or Badger or RocksDB?
Anything to add? Claudia? Nope. Thank you very much. Just classic DB, MS SQL, plus the cache. Okay, very, very good. And then Waleed is another question. Are you posting the slides? If not, can you share the Discord server in here?
So I'll be posting the slides, but still let me post it here.
Very, very good.
Right. So we are looking for contributions, right? So it's a fairly nascent product. We open sourced it last year, November, though we have some of the large unicorns in India as our customers, and we are looking towards outside India to expand our user base. But we are a fairly small company, right? So we are looking for people who can work with us to help us create a better vision, to work with us to build more features into it, right? So I'll be more than happy if any one of you feels interested, would want to contribute, would want to discuss, would want to get involved at any level for the Devtron specifically.
Very good. Well, I have a question. Prashant, have you ever taught in university?
Never.
You'd be a very good teacher. I'm just saying, from my opinion, like the way you structured your ideas, responding to questions, very interested in answering the questions as well. We've gone a little bit over time, but it was totally worth it. So I'm extremely happy with all the depth. I would say this, I think we will have to plan another meetup for later this year to perhaps get a little bit more technical, to see some of the things, maybe like you said, take a deep dive on some of these things. But I really, really liked it. And once again, is that we are talking about technical concepts, but we're also talking about cultural things that were mentioned by different folks out there. Thanks to Saudi and Waleed for your questions. They were very, very useful to drive the conversations in different areas. And I thank you as well, Prashant, for being so patient in how you answered them. We have a tradition. So Gorka, can you share our screen? Every time we do a meetup, we always have our graphic recorder, Angel, who's doing a visual representation of the topics that are being discussed here. So in a second, we will be able to share that with you. Oh, there you go. Prashant, you should be able to see that. So these are obviously, we talked about a lot more things. You talked about a lot more things, but I think Angel did a good job of getting some of the main tasks there, talking about the guardrails, showing responsibility, helping developers focus on the things that are important, all the things that are necessary in order for collaboration to happen. So anyway, very, 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 very great job, Prashant. Very, very nice to have you with us today. Gorka, if you can stop sharing my screen. As always, everyone, if you have an idea for a meetup, for a talk, you know how to get in touch with us, get in our Slack, check out our webpage. I really enjoyed the talk that we had today. And like I said, I certainly would love to have you back. So anyway, I think we got the links to the Discord server. Check out Devtron Labs, obviously a company with a lot of dynamic, interesting things that are happening. Prashant, thank you so much for your time today.
Thanks a lot for having me here. And thanks for this excellent audience that we have.
Yeah, really good audience. Yeah, great audience today. Thank you very much for all the questions. Looking forward to continuing the conversation in Slack. Prashant, I know you're very busy, but we already have some questions for you waiting for you. So anyway, we'll be talking soon.
Same here. Thank you. Take care.
All right, take care. Bye-bye.